So we talked about point estimates and sampling distributions to find values of an entire population in Chapter 6. In Chapter 7, we're going to take a look at a kind of a different aspect of this, which is rather than presenting a set number for a value of a population, so like we say something like 11% of the population is left-handed, we could also present this as a confidence interval. And what might we mean by a confidence interval, a lot of people have seen this before, but we're going to present a number within regards to like either a range of values, or we're going to take that point estimate and assign what we're going to call a margin of error to that. So it actually is a little bit more theoretically sound because we're never really absolutely sure of the percent of people who are left-handed. People are being born all the time. That number is going to be changing consistently. So presenting it in terms of an interval rather than a set number is really more true to what's actually happening in the real world. So the two statistics that we're going to focus on for constructing confidence intervals for this course are means and proportions. So we may calculate a confidence interval for the average blood pressure of a female, or we may do something like the percent of people who have brown hair. So these are the two that we're going to focus on in this class are means and proportions. The values that we will use to construct our confidence intervals are, if it's a mean, if we're going to work for means, it is going to be a sample mean. So we're going to go collect some data. Remember, the symbol for sample mean is X bar, and a margin of error, which we will call E. If we are calculating a confidence interval for a proportion, then the values that we need we need a sample proportion, which we call P hat, and also we need a margin of error. Okay, the next one says, when a statistician states we are 95% confident that the percentage of people who have a sibling is between 0.677 and 0.723, what do they mean by that? This is going to be one of the tougher things that we're going to need to be able to wrap our heads around. But what this statement right here, this 95% confidence that it's, so what we're saying is if we repeat this process over and over and over again, 95% of the time, we will have the true proportions of people having siblings somewhere in this confidence interval. And it's kind of a mouthful, but basically what we're saying is, if we repeat this experiment, again and again, ,95% of the time, our confidence interval will contain the true value. So again, it's really what we're saying here is this is how confident we are in our procedure. And yeah, it kind of means this gives us a confidence in our answer, but it really just says we might miss 5% of the time. You are not going to actually have the true percentage of people who have siblings in here. 95% of the time that when you repeat the sample and over and over again, you will, but 5 out of 100, or about 5% of the time you will miss. And then the last one we're going to take a look at here, this should actually be number 5. If you have a point estimate for the proportion of people who are left-handed based on a sample and you get 0.11, so we know that the p-hat value we collected, let's say we sampled 100 people and 11 of them were left-handed, we find that the sample is 0.11, and again, we'll work on this in class, but we calculate that our margin of error is 0.04. What are all of the ways that you could represent this interval? Well, there are a couple different ways. There is what I like to call the plus-minus notation, where what we do is we say, we think it's between 11%, but within a margin of error of 0.4. So we would present that as we think it's 11% with plus or minus the error of 0.04. Another way we could look at this is writing it as an interval. So if I look at this as a graph, we're going to have 11% in the middle, or 0.11. If I add the margin of error, we would be at 0.15. And if I subtract that margin of error, we're at 0.07. So if we were to present that as an interval, we could just list the upper and lower values. So 0.07, comma, 0.15. So these are going to be the two different ways, right here and right here, the plus-minus notation and the interval. These are going to be the two ways that we are asked to represent confidence intervals.